All right, here we go. We're gonna put, we're finding inverse. Finding inverse functions. Okay. All right. All right, here we go. So we are going to start with just one here. Start over here at 1, and we have a f of x is equal to 6x. And what you're going to do is, you know that f of x, the other name for it is y. So we're going to rewrite this as a y. Y equals 6 of x. And then what we're going to do is we're going to switch the x and the y and then solve. So we take what was y will now be x, and what was x will now be y. We just switch places. So now we have x equals 6y, right? And now we solve, and we go back to solving for y. So we would divide both sides by 6. And so now you have we'll say x over 6 equals y. I'm just going to kind of flop it to make it look good. I'm just going to switch them right here and say y equals x over 6. And then you can just move that x down right there. And so now we have y is equal to 1 over 6x. And then what you want to do is replace that y now with this inverse notation. So now we say this inverse notation is 1 over 6x. Okay? And you always double check yourself, and this is indeed our answer right there. Okay? So it really is. Oh, and then I guess if you want, you can do the verifying it. Is a suggestion. It's not entirely necessary. It's just to double check and see if you're right. So let's say, so we basically put them into each other. So if I take my f of x, and I'm going to actually put in I'm going to put that inside of this guy. In fact, actually, sometimes I prefer to use, when I have parentheses right next to each other, I like to use brackets, so it kind of looks a little bit, like, easier to distinguish. So now if we know that that's our 1 over 6x is that guy, and now we're going to put this back into this function here, or sorry, I put an equal sign, I meant that, and so now we're going to place wherever 6 is, or where x is, we're going to put this 1 over 6x in there. And notice that the 6 is canceled, and we're left with just x. And this is technically y equals x, basically. Or well, that is equal to x. I should have put that function in there. Put the x over 6. There. Nice. So you should always get you always should get like y equals x kind of idea whenever you do this inverse, because that's what we did. We set y equal to x. kind of thing, or we swap their places. I'm probably not saying that well, but anyway, but the main idea, the verification, I'm not too worried about, but rather just this main idea of just flipping the x's and y's. So on number 2, let's roll to number 2 now. So number 2 is f of x is equal to x plus 4. All right, and it's the same deal. Rewrite, you know that f of x is just another name of y, so we rewrite y equals x plus 4, and then we swap we're going to trade places, and now we have x is equal to y plus 4, and now you want to solve for y, so I'm going to move my 4 over, right? Giving us a x minus 4 equals y. I'm just going to kind of flip it because we're used to seeing that that look right there. And then you always want to replace, once you get to the end, to kind of finish it up by using this notation. That means the inverse function is now equal to that. And that is how you do that. So it's actually pretty straightforward. It is a pretty straightforward process. Literally, so here I'll kind of outline over here with, let's use purple here, with our steps. So this is your like starting place, right? You're starting right here, and then this first step right here, these are going to be our like steps. Steps is we switch y for x. They're just trading places. So we're just flipping it out right here, right? And then our next step, we just solve for that new y. That new y, right? Because it's like now that y's right there, we solve for it, right? Once we get it, once we get it right here, I'm just finishing up this one little video for someone had asked me. Once we get the y right here, all we have to do is rewrite the y in the inverse notation. And that's it. All right, awesome. Let me know if you have any questions later.